Good morning to all of you. Welcome to Vedavyasa Academy. In binomial theorem, we completed binomial expansion and x power k term, x power k coefficients of binomial, x power k coefficient and x power 0 coefficient, that is constant term. Multinomial completed and binomial theorem up to middle term completed. Now we are discussing about binomial theorem for rational index. Binomial theorem for rational index. Here, how to expand for rational index binomial theorem. The number of rational terms in the expansion of a power 1 by L plus b power 1 by m 1 by k whole power n is n by LCM of L comma k. Step of greatest integer function. When none of the L comma L and k is a factor of n and when L and k is a factor of n, at least one is a factor of n, then step of n by LCM of L comma k plus 1, where this step greatest integer function. Okay, all of you. Here, once again you see the number of rational terms in the expansion of a power 1 by L plus b power 1 by k whole power n is a step of n by LCM of L comma k. This is greatest integer function. When none of the L and k is a factor of n, means what? L and k not factor of n, then this is the number of the rational terms, number of the rational terms, where this denotes step of n by LCM of L comma k denotes greatest integer function. If at least one of L and k is a factor of n, then step of n by LCM of L plus k plus 1 are the number of rational terms in the expansion a power 1 by L plus b power 1 by k. Okay, all of you. This one complete. Here we have the problem. The number of irrational terms in 8 root 5 plus 6 root 2 whole power 100 is. So here we have the given expression 8th root 5 plus 6th root 2 whole power 100 equal to 5 power 1 by 8 plus 2 power 1 by 6 whole power 100. Then we have to check out this step of 100 n by LCM of L comma k is equal to 100 by LCM of 8 and 6. LCM of 8 comma 6 is equal to, this is 100 by LCM of 8 comma 6, 24. 24 is equal to this greatest integer function 4 point something. 100 by 24 is equal to, this is 4 point something, is equal to what? 4. Is equal to 4. So number of rational index in this are number of rational terms are 4. Number of irrational terms is equal to, number of terms in this expansion is what? 101 minus 4 is equal to 97. Here 8 comma 6, none of these factors of 100. 8 comma 6, none of 8 comma 6 are factors of 100. Then we take this one, 4 is the greatest integer function. Number of rational terms are 4. So number of irrational terms are 100. 101 minus 4 is equal to 97. That's all. Here we have the problem. If n is a positive integer, then root 3 plus 1 whole power 2n minus root 3 minus 1 whole power n. So here given expression root 3 plus 1 whole power 2n minus root 3 minus 1 whole power 2n. So root 3 plus 1 whole power 2n is equal to 2n c0 root 3 whole power n plus 2n c1 root 3 whole power 2n minus 1. This is power 2n plus 2n c2 root 3 whole power 2n minus 2 plus so on. Plus after term 2n cr root 3 whole power 2n minus r plus so on 2n cn root 3 whole power 2n cn. That's all. Okay. Here root 3 minus 1 whole power 2n is equal to 2n c0 root 3 whole power 2n minus 2n c1 root 3 whole power 2n minus 1 plus 2n c2 root 3 whole power 2n minus 2 minus so on plus minus 1 whole power r 2n cr root 3 whole power 2n minus r plus so on plus minus 1 whole power n. This is positive value 2n negative value minus 1 whole power n 2n into 2n cn. Okay, all of you. So you subtract this one root 3 plus 1 whole power 2n minus root 3 minus 1 whole power 2n is equal to this one cancel and odd terms are cancelled. Even terms are 2 into 2n C0 root 3 whole power 2n plus 2n C2 root 3 whole power 2n minus 2 plus so on like this. Okay, this is the root 3 plus 1 whole power 2n minus root 3 minus 1 whole power 2n expansion. Okay, all of you, that's all. Now we are going to discuss about binomial theorem for negative index. Binomial theorem for negative index. So, if n is a rational number, if n is a rational number, if n is a rational number, and also minus 1 and minus 1 less than x is less than 1. N is a rational number and minus 1 less than x less than 1. Then first one 1 plus x whole power n, 1 plus x whole power n is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 by 3 factorial into x cube plus so on like this plus n into n minus 1 into so on n minus r n minus n plus r minus 1 by r factorial into x power r plus so on up to infinity. Here 1 plus x whole power n is equal to 1 plus x whole power n is equal to here 1 plus nx plus n into n minus 1 by 2 factorial into x square n into n minus 1 n minus 2 by 3 factorial into x cube plus so on plus n into n minus 1 so on n minus r plus 1 n minus r plus 1 by r factorial into x power r plus so on up to infinity, where minus 1 less than x is less than 1. N is a rational number. If n is a rational number, 1 plus x whole power n is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 n minus 2 by 3 factorial x cube plus so on plus n into n minus 1 so on n minus r plus 1 by r factorial x power r plus so on infinity. When n is a rational number, minus 1 less than x is less than 1. B. Here 1 minus x whole power n is equal to 1 minus nx plus n into n minus 1 by 2 factorial x square minus n into n minus 1 into n minus 2 by 3 factorial x cube plus so on plus minus 1 whole power r n into n minus 1 into n minus 1 so on n minus r plus 1 by r factorial into x power r plus so on up to infinity. 1 plus x whole power n. This is 1 minus x whole power n. Okay, all of you. Where n is a rational number, minus 1 less than x less than 1. Here we have one more result, that is 1 plus x whole power minus n, negative index. 1 plus x whole power minus n, minus 1 less than x is less than 1 is equal to 1 plus this is n into x plus n into n plus 1 by 2 factorial into x power into x square n into n plus 1 by 2 factorial n into n plus 1 by 2 factorial x square plus n into n plus 1 into n plus 2 by 3 factorial x cube plus so on plus n into n plus 1 into n plus 1 so on n plus r minus 1 by r factorial x power r plus so on up to infinity. D. Next 1 minus x whole power minus n is equal to 1 minus nx plus n into n plus 1 by 2 factorial x square minus n into n plus 1 n plus 2 by 3 factorial x cube minus so on plus minus 1 whole power r n into n plus 1 so on n plus r minus 1 by r factorial x power r plus so on up to infinity. So these are the two important results when negative index is there. Index is negative. Before that we discussed about positive index and minus 1 less than x is less than 1. When negative index, then we have this is the results. Okay, all of you. That's all. Here binomial theorem for negative index. If p comma q are positive integers and mod x less than 1. P comma q are positive integers and mod x less than 1. So in this a 1 plus x whole power p by q equal to 1 plus p into x by q plus 1. This is p of p minus q by 2 factorial, here 1 factorial into x by q whole square plus p into p minus q into p minus 2q by 3 factorial into x by q whole cube plus so on plus this is p minus q p minus 2q and so on p minus r minus 1q by r factorial into x by q power r plus so on up to infinity. Here next 1 minus x whole power p by q is equal to 1 minus p by 1 factorial x by q plus p into p minus q by 2 factorial x by q whole square minus p into p minus q p minus 2q by 3 factorial x by q whole cube plus so on plus minus 1 whole power r p into p minus q p minus 2q and so on p minus of r minus 1 cube by r factorial into x by q whole power r plus so on up to infinity. If p comma q are positive integer, mod x is less than 1, these are the two results pulled. Okay, all of you. That's all. Here also we can written as 1 plus x whole power p by q sigma r is equal to 0 to p by q. or 0 to n, 0 to n. Here p into p minus q, p minus 2q, and so on, p minus of r minus 1 into q by r factorial into x power x by q power r. Okay, here b, here 1 minus x whole power p by q is equal to sigma r is equal to 0 to n, and p into p minus q, p minus 2q, and so on, p minus of r minus 1q by r factorial into x by q whole power r. Okay, this is the expansion can be written as like this. And also here this is minus 1 whole power r, minus 1 whole power r. Here we have the p comma q implies p by q is negative index, mod x less than 1, then what is the value? 1 plus x whole power p by q equal to, we can written as 1 minus p x by q plus p into p plus q by 2 factorial into x by q whole square, here by 1 factorial, plus minus p into p plus q into p plus 2q by 3 factorial into x by q whole cube, plus so on, plus here minus 1 whole power r into p into p plus q, p plus 2q, plus into so on, p plus r minus 1 cube by r factorial into x by q whole power r, plus so on up to infinity. Here 1 plus x whole power p by q, in this case you can write r sigma r is equal to 0 to 1 minus 1 whole power r into p into p plus q, p plus 2q, and so on, p plus of r minus 1 cube by r factorial into x by q whole power r. This is the one of the result. If p comma q, p by q is negative index, mod x is less than 1, this result holds. Okay, all of you, that's all. Here we have the one more result, b 1 minus x whole power p by q equal to 1 plus p by 1 factorial x by q plus 1 plus p into p plus q by 2 factorial into x by q whole square plus p into p plus q into p plus 2q by 3 factorial into x by q whole cube, plus so on, plus p into p plus q into p plus 2q, so on, p plus r minus 1 cube by r factorial into x by q whole power r, plus so on up to infinity. So 1 minus x whole power p by q can be written as sigma r is equal to 0 to infinity p into p plus q into p plus 2q and so on, p plus r minus 1q by r factorial into x by q whole power r is the one more result in the expansion of 1 minus q whole power p by q. Here we have the sum of the results. That imply that one, first one, 1 minus x whole power minus 1 is equal to 1 plus x square plus x cube plus so on plus x power r plus so on up to infinity. And second one, 1 minus x whole power 1 plus x whole power minus x is equal to 1 minus x plus x square minus x cube plus so on plus minus 1 whole power r into x power r plus so on up to infinity. And third one, 1 minus x whole power minus 2, 1 plus x plus 2x square plus 3x cube plus so on plus this is r plus 1 into x power r. This is 1 plus 2x and this is 3x square. This is 4x cube. This is plus so on up to infinity. Fourth one, 1 minus x, 1 plus x whole power minus 2 is equal to 1 minus 2x plus 3x square minus 4x cube plus so on plus minus 1 whole power r plus 1 into x power r plus so on up to infinity. Fifth one, 1 minus x whole power minus 3, 1 plus 3x plus 6x square plus 10x cube plus so on plus r plus 1 into r plus 2 x power r plus so on up to infinity. Here sixth result, 1 plus x whole power minus 3 is equal to 1 minus 3x plus 6x square minus 10x cube plus so on plus minus 1 whole power r plus 1 into r plus 2 x power r plus so on up to infinity. These are the very, very important results. You remember this one. Okay, all of you. That's all.